Which topic we were studying? Topic. I I think yeah, static frictions we were doing. Have we done double block problem? Have we done double block problem? Yes. Okay. So now we are going to talk about static friction, or you can say use of friction in circular motion. Okay. Friction in circular motion. Have we done this question? Have we done this question? Find minimum value of F such that block does not slip, small m. Okay. Have we done this, Deepika? Can you all see the screen now? This question is done. Okay. All right. All right. All right. Next question. This is a rotor and there is a block of mass m. This is mu and this is rotating with omega naught. This is rotating with omega naught. Radius is r. So question says find minimum value. Find minimum value of omega such that block does not fall. Block does not fall. Have we done this also? Okay, please solve. Give me the answer quickly. This question is similar to the previous question which I was asking you whether we have done or not. And concept is same. The way of things happening is Presley is saying root of G by mu r. Hmm. Vedant is saying root of G r by mu. Deepika is saying root of G by mu r. Jared is saying G by mu. Acha, whenever you solve any question, all of you, check the dimensional correctness of your answer. Just to give you example, Jared has given G by mu. Okay. Now dimensions of G is m1, no, only m naught L1 t minus 2 because it is acceleration. Mu is dimensionless. Mu is dimensionless. So your answer is coming out to be L1 t minus 2. Can this be the dimensions of omega? Jared, can this be the dimensions of omega? Now same answer is given by Wasim also. No. So as it cannot be, as the answer is not dimensionally correct, that means your answer is wrong. Okay. Similarly, other people can also verify the correctness by dimensional method. Verify the correctness by dimensional method. Okay. Now pay attention everyone. I am now going to solve this by proper method. So mg will be acting downward. Nobody can change that. If mg is acting downward, there will be some force which is counterbalancing it. Now that force can only be friction. So I am considering that it is Fs max. I am considering that Fs max because if it is lesser than that, block will fall. Now if Fs max is there, it must be mu n. So that means n will also be there, right? And that's it. The block, see, on this block, there can be two type of forces. One is contact force, one is non-contact force. Now in non-contact forces, there is only gravitation in this case. In non-contact forces, there is only gravitational. So we have mentioned that in contact forces, there can be two type of forces. One can be perpendicular, so that is normal reaction. One another can be along the plane, so that is friction. Now no other force can be there other than this. So let us start the talk. So for block along vertical, along vertical, so mg minus f max is equal to 0. So mg is equal to mu n, equation number 1. Okay, so this is along vertical. Now along horizontal. Now along horizontal. So along horizontal, what you can see is that n is the normal reaction and that is providing necessary centripetal force. So n is equal to m omega square N is equal to m omega square r. Okay, so that is equation number 2. So let us put this value in 1. So by 1 and 2, by 1 and 2. So mg is equal to mu m omega square r. So m got cancelled. So omega square is equal to g by mu r, and that gives us omega is equal to root of g by mu r. Okay, so that is the answer. Root of g by mu r is the answer. All right, any doubt, any question, any doubt, any question, anyone? Good, good. So let us move further. I hope you all have noted. Let us move further. Okay, okay. So next question. You can take it as question, you can take it as concept also. So there is a circular track. So this is a track which is circular in shape. This must be the center, okay, of the circle, and there is a vehicle. This is the vehicle which is going on this circular track. Okay. So this vehicle is going with some speed, and that speed is v. Obviously there will be some mass, that is m, and you cannot see the tires because this is the top view. Sometimes it is also called aerial view. Okay, so if you this car alone, it will look like this. Okay, road is rough, so mu is present. All right, now pay attention to what is happening in this whole scenario. Mg must be acting vertically downward. Mg must be acting vertically downward. I am showing it like this because there is no other way to show it. N must be acting vertically upward. So for vehicle, or you can say car, along vertical, along vertical. So N minus mg is equal to 0. Why? Because it is not flying in vertical direction, it is not accelerating in vertical direction, neither it is going inside the road in vertical direction. So in vertical direction, vehicle cannot have any acceleration, correct? Because beneath the vehicle road is there, so it cannot go inside, and this vehicle does not have facility to fly, so it cannot rise up. So there cannot be any acceleration in vertical direction. That's why n minus mg must have to be 0. All right. Now, is the motion of vehicle circular? Yes, it is circular. So there must be some centripetal force also. Yes, sir. There will be Fc, centripetal force, and this centripetal force is provided by friction. Okay. So friction acting between vehicle, obviously it will be through tires, but I am not talking about that. Friction acting between vehicle and road will provide necessary centripetal force. So Fc will be Fs max, and that will be equal to mv max square by r. Why I am saying so? Because the vehicle is trying to move with maximum possible speed. Okay, if vehicle is safe at maximum possible speed, then it can be safe even with lower speeds also. If vehicle is safe with maximum possible speed, it will be safe with lower speeds also. Now how much will be the value of Fs max? So Fs max will be mu n, so that will be mu mg. So from 2 and 3, from 2 and 3, so what we can see is m v max square upon r is equal to mu capital Mg. M got cancelled, so v max is equal to under the root of mu rg, under the root of mu rg. So this will be the value of v max. This will be the value of v max. So v max is equal to under the root of mu rg. Please note everyone, this is the maximum possible speed for the safe passage. This is the maximum possible speed for the safe passage of vehicle. All right, please note. So basically the point which is to be noted is, when a vehicle is going on circular turning, when a vehicle is going on circular turning, friction provides the necessary centripetal force. Friction the necessary centripetal for a vehicle going on circular turnings, friction provides the necessary centripetal force. Okay, please remember. So for a vehicle going on circular turnings, friction provides the necessary centripetal force. All right, now we are going to talk about banking on road. Please note, bank on road. What happens many times, the friction which is providing the necessary centripetal force is not sufficient. Okay, not sufficient for what? Providing the necessary centripetal force. So in that case, what happens? Often vehicles skid away from the center and accidents happen. That's why if you would have noticed, wherever circular turnings are there, they mention on circular turning go slow, okay, or accident prone zone, go slow. Why? Because at that point the higher speed will cause skidding or toppling of vehicle, and that can be really dangerous for life. So what is done at circular turnings, that roads are slightly tilted up from outer side. So on circular turnings, roads are slightly tilted up, slightly tilted up from outer side. Okay, this phenomena is called this banking on road. This phenomena is called banking on road. All right, so let us see how it is done. So suppose this was horizontal and the road is slightly tilted, though tilt is not this much as I have shown, but I needed to explain things. But in reality tilting is not this much. All right, it is very slight tilt. You don't even realize that tilting is there in the road. So this is theta angle, and earlier vehicle was like this. If the tilting would not have been there, if the tilting would not have been there, vehicle would have been like this. But due to tilting, now the vehicle is like this. Okay, now the vehicle is like this. Be very clear that it is the road which is tilted, so vehicle is on the tilted road. Now again, normal reaction will be there on the object or basically vehicle. Mg will also be acting vertically downward as usual. Okay, now if we resolve n into two components, if we resolve n into two components, so this angle would be theta, so this will also be theta. So vertically will be n cos theta and horizontally will be n sin theta. Okay, so for vehicle, for vehicle along vertical, what we can see, n cos theta minus mg is equal to 0. Equation number 1. N cos theta minus mg is equal to 0, and that is equation number. What we can see is n sin theta is equal to mv square by r. Mv square by r. Okay, so this is along horizontal. This is along horizontal. Now if we divide, so dividing 2 by 1, you should notice, you should pay attention that we have not considered friction in this case. So basically we are assuming that only tilting is there, friction is not there in this case, right? So what is happening in this circular turning, only normal reaction, or you can say tilting, is providing the necessary centripetal force for safe passage. For safe passage. So when we divide 2 by 1, what do we get is tan theta is equal to v square upon rg, and that gives us v is equal to under the root of rg tan theta. V comes out to be under the root of rg tan theta. Okay, so that is the value of v. That is the value of V. V is equal to under the root of Rg tan theta. Okay. Please note everyone. Understood everyone? All right. All right. So in first case we talked that only friction is present and it is a level horizontal road. In second case we talked that only tilting is present or only banking on road is present, and that is providing necessary centripetal force for safe passage of vehicle, right? But in reality, if tilting is there, friction will also be there. You don't have any switch to switch off friction on road. Suppose you are going on a vehicle and you are finding that friction is too much, let me switch it off. So there is no such technology available so far using which you can switch off the friction between your vehicle and road, correct? So friction will be there and it will act as per the presence, or you can say friction coefficient between vehicle and road, right? So in reality what should happen, friction and tilting both should be there, and that happens actually. So let us talk about the next case when both friction and banking are present. When both Next case when both friction and banking are present. When both friction and banking are present. Okay. So let us see what will happen in that case. So again, this is horizontal, this is the tilted road, this is the vehicle, all right. This is angle theta. Obviously, mg will act on the object, mg will act vertically downward. Nobody can change that. N will act perpendicular to surface. Nobody can change that. I have a question to ask. If a vehicle is going with faster speed, okay, if a vehicle is going with maximum speed, the tendency of vehicle to skid will be inward or outward? Please tell me. If vehicle is going with fast speed, the tendency to skid for the vehicle will be inward or outward? Please answer. Komal is saying outward. Pratyusha is saying outward. Ronald is saying outward. Zail is saying outward. Okay, okay. Abhilasha is saying inward. Sorry, that was in a different message. Okay, okay. So basically, all of you are saying it will be outward. All right, all right. Okay, everyone, please pay attention. Your answer is absolutely correct. Your answer is absolutely correct. And the vehicle will have tendency to skid outward if the speed is more. So now you tell me, if vehicle has tendency to skid outward, friction will act in which direction? Friction will act in inward direction, and friction we all know that it always acts parallel to the surface, so friction will be in this direction, and We are talking about maximum, so it will be Fs max. Fs max. So friction will be Fs max and value of friction will be mu n. Value of friction will be mu n. Is there any doubt about it? There should be no doubt. All right. All right. Now pay attention. Once again, we can resolve everything in vertical and horizontal. So if this angle is theta, this will be theta, this will be theta, and this will be theta. So the component along this direction will be, pay attention, this will be n sine theta, and you also have mu n cos theta. Similarly, in this direction, it will be n cos theta. Similarly, in this direction, it will be mu n sine theta. Okay. Why we have resolved everything? Listen very carefully and try to understand. Why we have resolved everything in vertical and horizontal? Because your vehicle is moving on a horizontal circular path. So we applied the force the way they are supposed to act. Okay. We mentioned the direction of forces the way they are supposed to act, but at the same time we know that the motion of vehicle will be horizontal. Okay. When you are moving in a vehicle on a horizontal road, even if it is tilted, the vehicle at that moment is moving on a horizontal path, right? So for safe passage, so along vertical, what we can see is n cos theta is upward, minus mg is downward, minus mu n sine theta is equal to 0. Okay, so basically that gives you n cos theta minus mu n sine theta is equal to mg. That is equation number 1. Horizontal, along horizontal. So along horizontal, what you can see is n sine theta plus mu n cos theta, and that should be equal to mv max square by r. mv max square by r. Now why we have taken v max? Because we have taken f as fs max. Can you see that? We have f as fs max, that's why we have taken v as v max. We are trying to find maximum possible speed of vehicle for safe passage. Okay, when we do the calculation based on that, then we can simply put a notice board on road. Okay, once signal will be there which will be telling, okay, maximum speed should be this much. If you are going beyond that, then pray for yourself. Okay, like so. This is equation number 2. If we divide 2 by 1, so dividing 2 by 1, then what we can do is V max square upon Rj is equal to V max square upon Rj is equal to n sine theta plus mu n cos theta upon n cos theta minus mu n sine theta. Okay, so n, so V max will be Rg sin theta plus mu cos theta upon cos theta minus mu sin theta. Let me use this is Vmax square. In next step, we'll be taking root. So the next thing becomes Vmax is equal to under the root Rg tan theta plus mu upon 1 minus mu tan theta. This is the value of Vmax. This is the value of Vmax. Please note. Please note everyone. Understood everyone? Understood everyone? Now there can be special cases also. What can be the special cases? Let us put theta is equal to 0 degree. So putting theta is equal to 0 degree. Everyone please check what is the value of Vmax that you are getting. When you are putting theta is equal to 0 degree, what is the value of Vmax that you are getting? Please give me the answer. Suhas is saying mu Rg. Absolutely correct, Suhas. Now, what is significance of that mu Rg? What is significance of that mu Rg? Everyone, please pay attention. Basically, when you are putting theta is equal to 0 degree, try to think you are bringing the object back on horizontal road. Because if theta is 0, there is no banking present in the road. And if there is no banking present in the road, that means the object or vehicle is moving on a horizontal circular path where only friction is present. And we have studied that. We have studied that. So tan theta will be tan 0 will be 0. So Vmax will be mu Rg. We have already talked about it. Okay. So when it will be purely horizontal road, Vmax will be mu Rg. Okay. Now special case 2. Putting, there is no banking. Correct. Samarth is saying under root of Rg tan theta. Okay. So if you are putting mu is equal to Vmax comes out to be under the root of Rg tan theta. Vmax will be under the root of Rg tan theta. What is significance of under root of Rg tan theta? That means road is frictionless but banking is present. Okay. When Vmax is equal to under root Rg tan theta, road is banked, road is banked but frictionless. We have also talked about this earlier. Okay, when only banking is present and friction is not there, then what will be the scenario? We have talked about this. Can you see it, Ram? Okay, good, good. So these are the cases when friction is helping us to move on circular paths. All right. Question. A car of mass 500 kg is moving on a circular turning of radius 20 meter if mu between tires and road is 0.5. Find maximum speed. Find maximum. Someone's mic is unmuted. Find maximum speed for safe passage of car. Find maximum speed for safe passage of car. Okay. So Vmax will be mu Rg, and that will be mu is half, R is 20 and G is 10. So that gives us 10 meter per second. Now 10 meter per second, if you see, is 30 kilometer per hour. Okay. So in such horizontal road, what you need to do is you need to make your vehicle extremely slow, because 30 kilometer per hour is really very slow speed. Correct. That's why that banking is required. That okay, 10 meter per second, that means 30 kilometer per hour is given by friction. Now let us take help of normal reaction also. So both, when they come together, things become better. Okay. So let it be. Next question. Angle as 30 degree, because the minimum value of tan is tan 30. Okay. That's why I have taken angle as 30. In reality, you don't find this angle. So if a road is banked by 30°, find maximum possible speed of safe passage of vehicle. Safe passage of vehicle if radius of circular path, if radius of circular is 20 meter. Please find. So answer will be under root of 200 by root 3. Okay. So this will be the answer. Question. IPQ. Find Vmax of car if both friction and banking are present. Please find. Please find everyone. Yeah, mu is 0.5, Samarth. So Vmax is equal to under the root of Rg tan theta plus mu upon 1 minus mu tan theta, right? Under the root of Rg tan 30 is 1 by root 3 plus 1 by 2 upon 1 minus 1 by root 3 into 1 by 2. So Rg becomes 200. Under root is there 200. Now this will be 2 plus root 3 upon 2 root 3 minus 1. This is the answer. This is the answer. Samarth, when you are saying root, it is 302.922. Is there root outside or root is not there? Samarth, with root, without root. Okay, so you are saying this much will be the value of speed. सावधानी हटी दुर्घटना घटी. Very nice, Samarth. Very nice. Okay, everyone, please don't make such mistakes. These are very painful mistakes. Okay, don't do such mistakes. Let us move further. So basically we have talked about NLM, we have talked about pulley questions, we have talked about weighing machine questions, we have talked about spring balance, we have talked about lift problems, we have talked about friction, we have talked about pseudo force, correct? Then we have talked about banking on road also. Okay. Okay, so one type of questions are left, and those are questions based on thrust. Thrust based question. Thrust based questions. So what are these thrust based questions? If you remember, I told you F is equal to dP by dt. F is equal to dP by dt. So rate of change of momentum is called force, and that is d by dt of mv, and that gives us m dv by dt plus v dm by dt. So this becomes ma, and this is f resultant, ma plus v dm by dt. Okay, so if you see this part, this component into picture. Okay, this component comes into picture only when mass of object is changing. If mass of object or system is changing, then this part comes into picture. Okay, for example, you have a balloon which is filled of gas, and if you open the knob, or if you pierce the balloon, gas comes out, gas is ejected. and due to that you can see the balloon moving in very funny way. So why this is happening? This is due to the thrust exerted by the gas which is going out of the balloon. When water comes out from a pipe with high speed, that pipe moves like a snake. You must have seen that. It becomes very difficult to hold it or catch it without getting wet. Why that happens? That also occurs due to the thrust caused by the water which is coming out with high speed. Okay, so this part v dm by dt is F thrust. F thrust is equal to v dm by dt. F thrust is v dm by dt, where v is the speed of ejected mass. That can be liquid, that can be gas, that can be even solid also. Okay, and dm by dt, dm by dt is the rate of rate of change of mass, rate of change of mass. Okay, so let us see how this can be used for solving question. For an object, or you can say from an object, from an object gases are coming out with 20 meters per second, and mass of gas coming out per second, coming out per second is 0.2 kg. Find thrust exerted by thrust exerted by gas on object. Okay, please find everyone. All right, so F thrust is equal to u relative into dm by dt. U relative is 20 into dm by dt is 0.4. U relative is 20 and dm by dt is 0.2 actually. So that becomes 4 Newton. That becomes 4 Newton. All right. Okay. Now same type of question can be created for water coming out of a pipe also. Okay. Now just to tell you, using the same principle, rockets are lifted. Okay. So lifting of rocket. Lifting of rocket. So how a rocket is lifted? Pay attention. This is a rocket. Initial mass of the rocket is m naught. Okay. Gases which are ejecting out of it are with speed u naught. Gases which are ejected out of it are being ejected with speed u naught. Okay. And the mass ejected is at the rate of m naught. M naught means small m naught. So that is the per kg it is ejected out. So let me write it in words. From a rocket of mass m naught, gases are being ejected. Gases are being ejected with speed u naught and and mass of gases ejected, mass of gases ejected is m naught kg per second. Mass of gases ejected is m naught kg per second. Okay. So the question says find speed of rocket as a function of time. Okay. So basically you need to derive the formula using which you can calculate the speed of rocket at any time t. Okay. So find speed of rocket as a function of time. Would you like to attempt it? Would you like to attempt it, everyone? Okay. Try it. Okay, everyone, please pay attention. Enough time given. Now, suppose at any time t, suppose at any time t, we are discussing the whole thing. Okay. So at that time t, what will happen? M is mass of this. So mg will be acting downward. M is mass of this, so mg will be acting downward. F thrust will be acting upward. Okay. What else? Nothing. So F resultant will be F thrust minus mg. Mg is due to gravity, which is acting downward, and F thrust is due to the thrust, which is acting upward. Now, how much is the value of m? So m will be m naught minus m naught into t, because t is the time, and how much mass is ejected per second? M naught. So in t time, total how much mass will be ejected? Not t. So what will be the mass remaining? M will be m is equal to m naught minus small m naught into t. Remember that. How much will be F thrust? So F thrust will be u relative into dm by dt. So u relative was how much? U relative was how much? It is given as u naught. Dm by dt is how much? M naught. So this is the value of F thrust. So F resultant, pay attention everyone, that will be M into A, and that will be equal to M naught into U naught minus Mg. M is M naught minus small m naught into T into G. Any doubt, any questions so far? Anyone? If you have any questions so far, please feel free to ask. Do not hesitate and ask, because after that things will be simply mathematical. Any doubt, any question? No doubt. Very nice. Now, good. Now this MA can be written as capital M. Now capital M is how much? Let it be capital M. Sir, whose mass is M? M is the mass of, Asmita, M is the mass of rocket at any time t. Because you are drawing FBD of rocket, that's why you are taking mass of rocket. Sandesh is asking, sir, how is the mass? M minus m naught t. See, try to understand. Initial mass of rocket is given as m naught. Okay, capital M naught. And gases are ejected. Gases are ejected from rocket per second. So mass of the rocket will change every moment. And how much will be the final mass? Final mass will be m naught, capital M naught minus small m naught t. Okay. So what I am doing, everyone, please pay attention. I am dividing both sides by capital M. So A will be small m naught u naught upon capital M naught minus small m naught t. Okay. Minus G. This will be your acceleration. This will be your acceleration. Any doubt in this? Any doubt in this? Okay, if you have no doubt in this, now things are very easy. A can be written as dV by dt. A can be written as dV by dt, and that is small m naught u naught upon capital M naught minus small m naught t minus g, which can be now further written as dv is equal to m naught u naught upon m naught minus m naught t dt minus g dt. Okay, so this is dv. What will be v? So v will be integration dv is equal to m naught u naught is anyway constant, integration dt upon m naught minus small m naught t minus g can be taken out, integration dt. Your time is going from 0 to t. Time is going from 0 to t. Velocity of rocket was initially 0, now it is v. Okay. So v comes out to be, my dear friends, m naught u naught. If you remember, I told you one formula. And what was the formula? Integration dx upon ax plus b is equal to 1 upon a log ax plus b plus c. C is constant. So I am going to use this formula for dt upon m naught minus m naught t. Okay, remember that. So m naught u naught in the bracket 1 upon minus m naught. So this is 1 upon a log of m naught minus m naught t, m naught minus m naught t, limit is from 0 to t, this bracket is closed, minus g, and this is t, limit is from 0 to t. So v comes out to be this m naught and this m naught is getting cancelled. Can you see that? So this is minus u naught, this minus of m naught I have taken there. Now I am going to apply limits. So log of m naught minus small m naught t minus, I'm going to put t is equal to 0 now. This will be log of m naught minus gt minus gt. So v comes out to be minus of u naught log of, now log a minus log b, log of a by b. So this will be m naught minus small m naught t upon capital M naught. Okay. The written as v is equal to, now I'm taking minus inside, so u naught into log of m naught upon m naught minus m naught t minus gt. This will be your answer. This will be your answer. Please note. How many of you got this answer? Samarth, you have used a minus sign. Samarth, you have used a minus sign. See that. No, you have written m naught upon m naught minus m naught t. This is the answer I am talking about. This I am talking about. I have. Okay. Understood everyone this? Have you understood this everyone? Okay. So usually this type of questions they don't ask. They simply ask question based on formula, and the formula is simple. F thrust is equal to U relative into dm by dt. So you should practice 8-10 questions of that type and you will become an expert. Only some common type of questions are asked which are there in your book. Hmm. Can we move further? Okay. Okay. Question. So this is an inclined plane. Half of it is rough and half of it is smooth. There is a block which starts from top of mass m. Okay. So if block released from rest if a block released from rest reaches the bottom with with zero final velocity, zero final velocity, find find value of find relation between actually find relation between theta and mu. Find relation between theta and mu. Okay, I told you that half of the inclined plane is smooth and half is rough. Okay, solve. Show me the working, Wasim. How you have got the answer? This question can be solved by two ways. One way is if you apply acceleration at both the places and then you apply equations of motion. Okay, so suppose this is point A, this is point B, this is point C. So during AB, U is equal to 0, S is equal to L. I am considering that length as L. Okay. V is equal to question mark and A is equal to G sine theta. A is equal to G sine theta, because if this is mg, this will be mg cos theta, which will be balanced by n, and this will be mg sine theta. Okay, so what we can do, we can apply by v square is equal to u square plus 2as. So v square comes out to be 2 into g sine theta into L. This is equation number 1. Okay, this will be velocity at point B. You can call it VB. You can call it as VB. All right. Now, during BC, so U will be VB, which is initial velocity, which we have just calculated. Final V will be 0, because the question is saying that the block is reaching ground with 0 velocity. S will be L, that is given because half length, half length. So both lengths will be LL. And A will be, now pay attention, during this part mg sin theta is acting downward and mu mg cos theta is acting upward. So A will be g sin theta minus mu g cos theta, and it is constant. During this half it is constant. So again, if we apply by v square is equal to u square plus 2s, so 0 square, because finally it has went back to 0, u square means vb square plus 2 into a is g sin theta minus mu g cos theta into L. All right, so let us put from 1. So when we are putting from 1, 0 is equal to vb square means 2gl sin theta into L plus 2g sin theta into L minus 2 mu g cos theta into L. All right, so 2gl 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 you can see will get cancelled. So what is left with us? 0 is equal to sin theta plus sin theta minus 2 cos theta. Mu is also there. Hmm. 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 Are we missing out something? Something is tan theta should be actually check. We have so 2 sin theta is equal to 2 mu cos theta. I think something is missing, so tan theta comes out to be mu. Somewhere we have made some slight calculation mistake somewhere. V square is equal, first case V square is equal to, this is VB square, which is 2gl sine theta. Okay, now when we used it, so 2gl sine theta, so why we multiplied L here, not needed. All right, plus 2 and g sine theta minus mu g cos theta into L, plus 2 g sine theta minus mu g cos theta. Okay, this 2 and this 2 will be 4. This 2 and this 2 will be 4. So this is 2 sine theta and 2 sine theta. So this is 4 sine theta is equal to this. So tan theta is equal to mu by 2. This should be the answer. Check everyone. Check everyone. You have not shown working, Wasim. Even if it is you are solving using work energy theorem, show me the working. Understood everyone? Any doubt, any question in this? Okay. So keep solving questions everyone. We'll study further in next class, and that is enough for today. Find out if any topic is left in this chapter. If not, then we can start